Hello there and welcome to this Pandas Challenge, day 1 of 30. My name is Valentine and I'll be your instructor. I'll be taking you through the challenges that's from day 1 to day 30 and helping you to solidify your understanding or your application of the Pandas library when it comes to performing data manipulation, data cleaning, data wrangling, as well as data analysis. So the idea is that by the end of it all, you should be in a position to perform any sort of data cleaning or data manipulation task that you might have in mind, depending on whatever complexity that technique entails. So let's get started. You can access this link that will provide you with a practice resource for this workshop in the description section. So click on the practice resource link. It should take you to this page. Then you can click on the sample practice resource to get started, which will look like this. So in this challenge, we are going to go through 10 different concepts in relation to Pandas. And each and every day for 30 days, we'll be going through different different challenges, different concepts. Some of them might be repeated, some of them might be a whole lot easier, but the idea is that at the end of it all, you have concepts in relation to Pandas at your fingertips. So when it comes to data analysis, it will feel second nature. Something else to note is that we've also provided a way for you to be able to receive these challenges on your email. So have a look at the description section. There will be also another link that will sign you up for the list, the email list that will allow you to be able to keep on track. So every day you'll be receiving the challenges, the Pandas challenges. So yeah, so let's get started. So once you have opened the sample practice notebook, but if you're an Afterwork member, you can open the practice notebook, which will contain all the challenges. So once you've opened the sample practice notebook, then we can start. So save this as a copy in Drive by going to File, then save a copy in Drive. It should open a new copy of this notebook in a new tab, and then we can get started. You can pause the video, by the way, if I am too fast, so that you can be able to perform some of those steps. So once you do that, you're going to go through prerequisites. But before I do that, I'll just open mine in playground mode. I don't want to make any changes to this notebook. And then I'm good to go. So once you have the copy, you can click on connect. Once you have the copy of the notebook, go to that copy and click on connect to connect the notebook to Google servers. And then we can get started. So it will show at the very top right, connected. And that will mean that we are good to go. You'll see a check. A green check. Now we're connected. All right, prerequisites. We'll start off by importing the Pandas library. So this is how we import it. Import Pandas as PD. So we use the import keyword and we rename this library as PD. So in any place in our code where we use PD, that's in any instance, we're going to be accessing Pandas. So starting off with our first concept, because this is our first challenge, we're just going to quickly learn how to import data from a CSV file, but you can import data from different files, Excel files, even JSON files, even from SQL files. So in our case here, we just want to read data that we can access from this link. So we will use read CSV function from Pandas and store that data set inside the df data frame or df variable and preview it. So let's run this and run this again. If in case you hear about terms that are a bit more complex, like variables, and it's your first time learning a programming language, feel free to pause this video and go to another video that we have on Python fundamentals. We actually have a series. You can choose whatever industry you're in. Maybe it's in healthcare. You can choose to go through just the one on healthcare, Pandas Python fundamentals for healthcare. That way you will be well versed with regards to the content. So all right, so that's it with regards to this concept. Work on the challenge that we give you here. It will just entail helping you to implement this concept that we have learned, how to import data into a data frame, which is a Pandas, which is a tabular data structure that stores data in rows and columns. So, and then we can perform further techniques on that data frame. So here we have df data frame, and we are performing now here in this next step. We are applying the head function to the df data frame to preview the first 5 records in order to understand its structure. Like you can see, we have multiple columns and we have multiple records, and they store information about servers. All right, moving on, pause the video, work on the challenge, and then once you're done, we can continue. If you're an Afterwork member, we also have provided the solution notebook, so you can cross-check on that. Becoming an Afterwork member isn't just a few dollars, and it supports our work as well. And you get access to all the resources on our platform, by the way. All right, moving on, indexing and selection in Pandas. So we can decide to specify which columns we would want to select using what is called the lock method. So sometimes you might only want to work with specific columns out of maybe 100 columns. That it just makes our work easier. So how can we be able to do that? So here we're going to learn how to select specific columns using this approach. You can use other approaches, but the idea here is, it's a challenge. We're learning how to work with Pandas from different perspectives. So here we're going to load our data set, which we can see it's sales data, but it contains information about servers. And whether some of them are in production, development, status. This data set is different from the previous one, by the way. And then once we have done that, we can select specific columns using the lock function or the lock method. So here we are using, we are applying the lock method to the sales data frame. So this is the data frame that we created. So sales data, then we apply the lock method, and then we specify that we want to select all the records. So that's where we are using the double colon. That's why we are using a double colon to select that we want to select all the records. Comma, then we specify the columns as a list, as a Python list. So the first element in that list, because a list has square brackets, so and the whatever is in that square bracket is considered to be an item or an element. So here we are specifying that we want to select server name column, operating system, and memory GB. So we want to work with this column, this other column, as well as this other column. And we display those columns here. That's one of the ways that we can be able to use, but there are other ways that you can select columns. This is just for learning how to just work with different techniques in Pandas. We can also filter data based on a condition. So assuming that we wanted to filter for maybe operating system where it's Ubuntu top 20.0, we can do that. But we can also decide to filter this data, that sales data, based on maybe status, where status is active. So for example, we can decide to reference the data frame, then we use square brackets, and inside we specify the condition that we want to use. We want to select, in that condition, we want, which normally we would call it, what we have here is actually called a Boolean vector. But now, just know that it's a condition for ease of understanding. So in our case here, we have sales data, then status. We want to specify the status column or status column, where the value equal to, so we use double equal sign, we don't use one, equal to active. So if the status in that column is equals to active, then we are going to display it, and that's what we get as active servers. So you can see the records that we have here are for active servers. All right. Pause the video and then work on the challenge. Again, if you're an Afterwork member, you'll get the resources as well as a solution notebook, so you'll get more. But for sample, we don't have a challenge for that. We have a challenge for the next section. All right, moving on, handling missing data in Pandas. So sometimes you might want to handle missing data, maybe because the outcome of our work will be important and it can be affected by if our data set has missing data. So let's first of all load this data set, another sales data set. This is how the data set looks like. Assuming that we wanted to check how many values for each column are missing, we can use the isNull.sum function. So we apply the isNull function to sales data, and the outcome of that, we apply the sum function to that, and then we store the outcome in missing values and then display missing values. So what we have here, you can see we have server name 0, means there aren't any missing values in that column. Same case with IP address, operating system, but in memory GB and storage GB, these two columns, we have missing values, and you can even see one which is there. And yeah, so this just gives us a good idea of how many missing values there are for each column. So to be able to fill in missing values with maybe the mean value of that column, maybe it might be the best approach that we've determined, then we can be able to use the mean function. So what we do actually is, first of all, we specify the column that we want to fill in the missing values for. Here it's how we select a column. So sales data, then memory GB. We are selecting memory GB inside the sales data frame and applying this function. So fill NA. And then inside the fill NA function, there are two different inputs that we are giving it. We are giving it this particular value, which is the mean value of memory GB. So this is how we calculate the mean value of memory GB. That's the memory GB column. And in place, we specify in place to be true, which means that we want to apply the change that we have specified here using the fill NA function to the original data frame. So we will apply this operation in place is equals to true. We'll just ensure that it performs the operation on the original data frame, that's sales data. And if we run this, we should be okay. So if we display again, we can, this is filling in missing values for this one column, but we can decide to also drop missing values instead of filling them in. So if any of the records has a missing value for storage, the column, storage TB column, we're going to drop that record. So we're also doing that. We're dropping rows with missing values in the storage TB column. So essentially here, in our final data frame, we won't have any missing values because we've handled them. And you'll see in our case here, when we check for missing values again, we have 0 missing values. So which means we've sorted it out. By the way, we have a Python course on handling missing values only. You can always check it out on our platform as well. So pause the video and then work on this challenge that comes up next. Group by in Pandas. Sometimes you might want to summarize data based off a bigger table. So you might have a table with 100 columns, but we just want a smaller table that gives us a summary. So it's essentially a pivot table. So let's first of all load this data set, which we have here. Then we can decide to group the data. So now let's create a pivot table, which sometimes in Python you can say grouping data, but it's essentially, you can also say pivot, creating a pivot table, but here we are grouping the data by the location column. So we want a smaller table to have location column, and we also want it to have the memory GB column. So the pivot table should have location and memory GB, but for memory GB, which is this column, we want to have the sum of memory GB for each location. So you could have, here we have multiple records, including for New York, you'll have multiple records. And what will happen is that you'll have a smaller table that will have the location as well as the sum of the memory for each location. Just tell us in terms of capacity, how much memory we have available in that location. And we apply that sum using the sum, we perform that sum operation using the sum function, and then we apply the reset index function to ensure that our final outcome is a Pandas data frame. It's a data frame that we can work with later. So here we've got our outcome. So we have location and memory. So you can see location one table and memory on the other side. And we can do a whole lot with this. We can even decide to sort this in ascending order to get the location where we have a lot of memory. And that can be used for just making other decisions that might come in handy depending on the context. All right, pause the video if you're an Afterwork member and work on the challenge. All right, moving on, Boolean indexing filtering. So sometimes you might want to perform filtering, but now using Boolean index. Actually, it's what we had done here, selection. In our selection section, indexing and selection, this is what we are doing. Here we are actually performing Boolean indexing. So in this section, we are going first of all to load this data set, which again will contain just some information about employees. And what we want to do is to filter for employees who have salary greater than 85,000. Like this particular person, Johnson, the same case, just Johnson and other employees. So what we normally do is to create a Boolean mask, which we create here, or Boolean vector. I mentioned vector, but we just proper terminology would be a Boolean mask. Then we say that we want to, here we're just specifying the column. or specifying the column, and then we use a greater sign to specify that we want to get values greater than, then we specify the number. So values greater than 85,000. So this is essentially a condition, but we call it a Boolean mask. We store it in the mask variable, and then we pass this mask variable to the square brackets in the next section in order to filter the data set, and then our filtered data would be stored here, and then we can display that filtered data. So the records that we get have values for salary greater than 85,000. And you'll note that it's not including records with 85,000. So you'd have to change this to equals to, is greater than or equal to. That's an operation that you can also apply if you want. Pause the video and then work on the challenge. Moving on, we might want to reshape our data using a pivot table. So assuming here initially we created let me go to section 4. We created a summary table that has location and memory GB. But what if we wanted location? We also wanted environment, etc. We could actually do multiple group bys, but using this concept that we're going to learn now, we can be able to restructure our data to be able to just gain an idea of records across maybe another category. So for example, in our case, we are going to create a pivot table, summary table, that has location, but then it has columns for environment. So in the environment, let me load this data set. In the environment variable, which you see here, we have production, we have development, we have production, we have staging. So we have production, development, and staging, 3 values. So we'll have a pivot table with location, then production, then development, then staging, and then it will tell us the mean number of values of memory for each and every location. So that's what we're going to get here. So we're going to get a table that has location. So that's what we are indexing by, location. Then we are going to have the development, the environment. So development, production, and staging. So it tells us the different, the average number of servers for each and every location. So you could have, maybe New York has different servers, but it gives you the number of memory GB per particular that location. But we could also do sum. So let's change this to sum to find the sum of that. So this is now the count of, like for this first one, we don't have any servers in development or in production, but we have some in staging, and this is their memory capacity for those ones, etc. So again, that is just an easier way of just being able to create, to visualize data across different categories versus maybe another category that you want, let's say, for example, location. All right, pause the video and then work on the challenge for After Work members. All right, moving on, data filtering, selection based on multiple columns. So initially we had, again, I'll go back to Boolean index filtering. So here we decided to create just one condition, but what if we had multiple conditions? How do we do that operation? So assuming we have this data set and we wanted to select records where operating system is equals to maybe Windows Server 2016 and CPU cores greater than 4. How do we do that? So we can decide to reference the data frame, then square brackets, and then we specify our condition. The first condition, which is what you see here, we enclose it in parentheses, as you can see here, and then we use an ampersand. An ampersand would be a logical operator. I don't know whether you're not able to see here. You can see we use an ampersand, which is a logical operator, which is an and sign, to specify that we also want to include another condition, which is what we have here. So if these two conditions turn out to be true, you enclose them in parentheses, if those particular conditions turn out to be true for a record, that record would be filtered. But if only one turns out to be true, then that record won't be filtered. If we want only one record to turn on, only one condition to be satisfied for us to be able to filter, we usually use a pipe, pipe operator, logic operator, which is what you're seeing there, which I've added here. So yeah. All right, so let's run that and we can be able to display the data set and we are good to go. All right. Pause the video and then work on the challenge. Moving on, we can use data cleaning techniques in Pandas to ensure that our data set is accurate and consistent. So there are many data cleaning techniques we'll cover in the course of this particular series of challenges. But for today, we are going to learn two of them. One is just being able to drop duplicates, and another one is being able to convert data types, so which are just classifications that we assign to columns in order to perform some operations. Like we can assign maybe an integer data type to a age column so that we can be able to perform mathematical operation on that particular column. So in our case, let's load this data set. It's a new data set. It's not like the previous one. Just note that it might have the same information, but it's slightly different. Then we check for data types using the dtypes property. So we applied to the df data frame that we created. Check the data types. So here we can see server name, which is the first column, has object, which means it's a string. It has textual data. So in Python or Pandas, we would normally represent textual data using the object data type. Then we have IP address has object as well, operating system object. Memory, we have int64, which is integers form, but there's also other types of integer data types that allow us to hold just data much more efficiently. There's int32, int16, int8, but here we're just assigning it to int64. There is storage, which is integer, CPU cores integer, network bandwidth float, etc. So to drop the duplicates in this data frame, we apply the drop underscore duplicates function, and we specify in place to be true to apply the change to the original data frame. We'll have dropped the duplicates. To convert memory GB, that's memory GB, to string, so it will have object. We use the as type, so we reference the column name, then we apply as type function to that column, and we pass a string str to represent the string data type that we want to apply to this column. So essentially, we should end up having memory GB having object. Here we also do a similar operation where we apply the integer data type to the network bandwidth, but now here we're going to have int64. Then we check our data types here. So let's run this. And then let's run this. So here you can see we have for memory GB, we have object. And for network bandwidth, we have int because of the integer bit over there. Pause the video and then work on the challenge. Statistical analysis. We can perform statistical analysis in Pandas to just gain insights into just the underlying patterns. For example, we can calculate for mean, median, standard deviation, also correlation, whether the, values of one column change, also that happens to the other values in the other column, etc. So let's check on this data set. So we're going to display this data set. It has the following information. And then we can calculate the mean of sales amount. So if we wanted to calculate the mean of this particular column, we can decide to reference the column name, then apply the mean function, and store the result in mean sales amount, and we can print out our outcome is that. We don't need to use the print function, but we can always do that if we want. It will give us some more information, but this is a mean. We do the same thing for median. We apply median for quantity using the median function, and we can print it out. So it will tell us median quantity, and then median. This is the median. Standard deviation of profit column. So this is the same thing. We use std. Then we specify the column, and then we store the result in a new variable called std dev profit, and then print out that. and correlation. So we can determine correlation between two variables, whether the values within that value change as the other values or the values in the other columns also change. So quantity and sales amount, we can see we have 0.9, which is normally, in terms of interpretation, it means that these two variables have a high correlation, which means that as values of quantity increase, sales amount also increases. Yeah, so yeah. Pause the video and then work on the challenge. Moving on, time series resampling. So sometimes you might want to do what is called time series resampling. So time series just involves analyzing data that has some sort of period or time component to it. So it could be that you have collected, or data has been collected over time. So, and we would want to analyze that data. So we would perform time series analysis to that data. So we can perform also time series analysis techniques using Pandas, and this is one of the techniques that we can perform. So we can decide to do what is called resampling. Resampling just means changing the frequency of the data. So for example, in this data set that I've loaded, here we have the date column. So date, it's per day. So you can see this is 01, 02, 03, 04. So the frequency of this data, which is time series data because it has a date component, is, you know, based on the date. It's actually a day format. So we can decide to instead change this to weekly, so that we have a summary, a record that has information about, let's say, week per week. So it has just week. So for example, we could decide to resample the data from, let's say, daily to weekly frequency to calculate now the weekly sum of sales. So for example, we might want to have for this first week, maybe what's the sales, total sales, etc. So, but before we do that, we need to convert the date time column to a date time format. It's like applying a date time data type. So when we're working with date data, we would want to be able to apply date functions and be able to perform date techniques. Then we will need to convert that date column to a date time format. And then we set that date column as an index for being able to perform just time series operations. Once we do that, we now resample. So we resample from daily to, initially it was daily, so which was here, to now weekly. So W, capital W would mean that we would have the weekly sum of sales, and we apply the sum function for that, and we then display the sum monthly sales. Like you can see here, we have this is not monthly. I'm reading the monthly here, but it's supposed to be weekly, by the way. Weekly, that doesn't matter. So I just changed that. Oh, sorry, I need to rerun this, and then rerun this again. So you can see we start on the 3rd. On the 3rd, we have 1,500. Then on the 10th, 7 days after, we have 3,900. These are the sum of sales, of total sales for that week. The same case goes on for the rest of the week. So here, essentially, what's happening is that we are essentially having to have the sum of the whatever variable that we want represented within this new data frame, that we can decide to even create some sort of line graph or time series graph on. All right, pause the video and then work on the challenge. And if you're an Afterwork member, then you can always feel free to check the sample solution. So what's next after this? Day 2 of the Pandas challenge. We'll have up until day 30. And the idea is that by the time we even get to day 5, 6, 7, you're already accustomed to some of these techniques, and they become second nature, and you can use them without even thinking so much about referencing. It will be just, if you have an idea of, in terms of implementation, out of the box, you could always implement them quickly. And yeah, so this challenge will continue. So what's next? I would highly advise you to continue the challenges. We'll be posting them every day. And yeah, if you would want to continue practicing more, we only have a few challenges. you can always consider becoming an afterwork member. If you did like this video, you got to learn something important, be sure to give this video a thumbs up. And if you want to be informed when we post such future courses or challenges, be sure to subscribe. All the best in your learning journey. Bye-bye.